Hi everyone, I'm Wayne. This is my first YouTube video, so we'll see how this goes. Hopefully it's interesting. But I don't know anything about video editing or anything, so I'm just going to wing it, and we'll see how this goes, if I do another one or not, or if people find it interesting or whatever. But basically the idea for this was I saw that Skype was being shut down, or Microsoft announced that they're shutting down Skype at the end of the month or something. And it reminded me that I have a long history with voice over the internet, including with Skype. And so I wanted to tell that story because I hope it's interesting. I think it's interesting. Maybe I'm the only one. We'll see. All right. So the background before voice over the internet was that we've always wanted to, and part of this is because I'm a geek for technology and history of technology. So I'll tell a little bit of this story. So the first sort of attempt at long distance real-time communication was the telegraph. If you ignore like signal mirrors and smoke signals or whatever, the telegraph was how we first sort of were able to communicate immediately over long distance. And I just read a book, so I'll plug the book. It's one of these Stephen Ambrose books. He writes about a lot of things like this, interesting historical events. This one was about the Transcontinental Railroad. So there was a lot of change going on at that time. So all the stuff around the railroad was amazing to read about and recall. They were going from two ends of the country. It was like Nebraska or something. And then Sacramento, I think, was on the other end, something like that. And so they were going toward each other. The western side was the railroad barons you hear about, like Stanford and J. Paul Getty or something. I forget who the other ones were. And so, but along next to the railroad was the telegraph. So that's how they were able to keep track from the end of the track back to New York or wherever, is because they actually were building the telegraph alongside the railroad. And so then they could tell about progress, they could order more provisions or whatever they were doing to get all the materials to the end of the track so that they could keep building and get ahead of it. So so that's interesting. But then also interesting was the fact that the transatlantic cable came online right then. And so they were able to announce the end of the railroad across also, when they met in Promontory Point or whatever, that was able to be announced all the way across the Atlantic. And so they had this semi-global telegraph. Now that's also interesting just because I thought because you couldn't just say, go into town and say, I want to send a telegraph to a random city and it would just get there. They had to have a relay language to say, okay, this telegraph needs to go to Des Moines, Iowa. Therefore, in my town, I can only talk to the next town, or wherever number of towns where you have a physical cable. And so you had to send it to one of those towns, and then they would know that it's going to Des Moines and have to relay it on to the next town. So it wasn't like really real time because you had to get people to sit there and type the Morse code in or whatever. So anyway, I thought that was interesting. But then when they did the first telephone networks, same thing, except they were a little smarter. They had patch panels. So now you could connect the caller to the callee, and you would go to an operator and she would say, number please, and you would say KL525 or whatever, and that would then start the process to get the connection made from the patch on one side to the other one and out to the other relay point or whatever, and finally it would ring down the line to the home, and it would ring the bell on the other side, and if they picked it up, the circuit would be connected, and then you could talk. Okay, so that's fine. And then, though, they had to, A, that got more complicated, but then B, they had to automate it because you didn't want every call having a human in it. So that's when they had the rotary phone dials, and so the PBXs, the back-end things that automatically connected based on those rotary dial things, and then eventually the DTMF tones. There was a whole big infrastructure of those, and it was expensive to pay for a long distance call within the US, but certainly an international call was super expensive. And that's still true, I guess. So, yeah. So the impetus for Skype was a combination of the improvements to the network, the internet network, data network, and the desire to get around this too expensive analog or digital, it was digital by then, but phone network. So how does that play to me? So then they invented Skype, and that provided that. And I used Skype for years because I had a remote Teams that it was expensive to call them. And so I would use Skype to do face-to-face or one-to-one calling. I would also use Skype to get to their cell phone, and that was because Skype had a feature called Skype Out, where you would say, I want to get to this number in Israel. My team was near Jerusalem, and there would be a phone number. And so the internet portion, it would go to someplace in Israel, and then it would initiate a call from a cell or a phone network out to that cell phone, and then they would charge me, but it was only like 2 cents a minute. So it was vastly cheaper than a regular cell call, international cell call. Okay, so back to me. When I got out of grad school, it was 1990. Well, when I was in grad school, I was able to leverage the research network to be able to do some things online, but not much. You could like see message boards and porn chats, I guess, or I don't even know what they all were. There was a bunch of message boards that you could get research topics, but random billboard topics too. Anyway, so when I started work at Oracle, they had corporate networks now, and this was often like VMware or IBM or some of these other companies, and then you could connect your computer to other servers in your company, or you could have print jobs. You could send print jobs to the printer because they were on the corporate LAN, local access network. So that was that, and then we still had dial-up at the home. So I had 64 kilobits, and then ISDN line with 2 channels got me to like 128 kilobits per second. But even in the beginning of that, I still had an acoustic modem for a little while, and then the modems became, built into the computer, the Mac. I have always had Macs since graduate school. But anyway, for the IBM PCs, you had to like get a networking card to plug into it, or a modem to plug into the phone network. And so we had that for many years. So I left Oracle in '93. I had built a graphical query builder, or wrote a graphical query builder. And that used client server to talk to the Oracle instance. And they had network libraries, and it was a nightmare. So I go to a startup called Latitude Communications, and that was a super cool startup. I learned a lot about telephony because the product was a voice conferencing bridge. You would connect it up to the corporate PBX, and people would dial an extension to get into the system, and they would hear welcome to meeting place. You would enter a meeting ID, and then you would get joined with other people, and you could talk and have a conference call. And we supported, like, it was initially like 128 people at a time, and then you could network them, and we got up to 1,000 and whatever. So these could be really big systems. But that's where I had to learn about echo or line echo versus acoustic echo and noise canceling and all the stuff that you do for building a telephony product. These guys, the back-end guys, John Yantz and all these people, Gary Scravatinas and all these people, they knew the telephony. So, but I just did the GUI client programming. It was like Windows 3.1. But anyway, I had to learn all that. In fact, that yellow jersey was from a version 2.0 of that product. And we sold it to, we had companies like, it was like 3Com and Agilent, HP, Credit Suisse First Boston, Fidelity, United Healthcare. Sold it back to Oracle. But anyway, so we had an IPO in like 99, and then the bubble burst. We lost our biggest customer, HP, and so we ended up starting to negotiate with Cisco to buy us. And at that time, when we were kind of going down after the bubble burst, our 500th customer was Webvan, by the way. I looked that up and I remembered that, or I looked it up. So anyway, we were doing a lot more with voice over IP now. So originally these were digital telephony trunks. They were T1 cards or T1 cables or whatever that connecting was. And that's how you connected to the PBXs to get into those big telephony systems. Toward the end, though, I started designing and building some of these big voice over IP systems. So I built literally in our lab, like an 2,000 port system that was connecting to these big Cisco voice boxes. It's like a call manager box or something. I think it wasn't even the call manager. We did integrate with call manager, but this DSP system that we connected to, it was like a AS7410 or something. I forget the number. It was some big $150,000 Cisco box. And so I designed the system for Oracle. And then I built other ones for like some shitty data center in Nebraska for United Healthcare. And at the end, I designed, but I left before it was built, a massive system for Cisco after they bought us. So anyway, I was living with all the call manager configurations, the bit rates, the quality of service. One of the things why Skype does not work so well is the network is unpredictable. The network packet structure is not a good design for asynchronous real-time communication. So Skype had to shoehorn itself onto this network like a virus. I'll talk a little bit more about that in a minute. But anyway, at Cisco, I was learning all about this voice over IP stuff so that we could debug and build and ship all this voice conferencing. My team, it was a small team, but we built a service bureau like WebEx. And we built it, it took credit cards, the whole thing. We built it in a cage, in a data center, halfway down Central Expressway. I think it was the Equinix facility. And it was crazy. We spent all this time there. Anyway, I built that out. So I decided I wanted to change from the Cisco world. I wanted to try something different. So I got a referral. Shout out to Randy Schaup. He helped me get a job at the eBay in their corporate architecture group. Shout out Alok Banot, DJ Patil, Scott Pritchard. Yeah. Sorry if I messed that pronunciation up. Dan Pritchard. So anyway, I go there, and one of the reasons why they hired me is because I had two things. One is I had this voice over IP background, a fair bit of software distributed system design, but also they had just bought Skype for $2.8 billion. And we didn't even know why the hell they bought Skype, or I didn't. It was just like, well, what is this used for? Or, in theory, eBay sellers could then answer questions in real time from potential buyers. But of course, they don't want to do that, but that's why they're selling things on eBay. They don't want to talk to, random people in the world or whatever. But anyway, so I go there, and we were building service-oriented architecture stuff, like a service bus that was going to be used around the eBay multi-corporate network, like PayPal, Rent.com, Ticket, StubHub. I forget what the other one, StubHub, I think. Anyway, so there was many properties that eBay had purchased, and they didn't integrate well. So our job was to build, there was an identity management system, as well as this service bus. So we were building that, but we were also loaning ourselves out to other projects as software architects. And so I was chosen or whatever to work on a Skype integration. So that's why I was one of the reasons I was hired over to eBay, and B, I actually did work on an eBay Skype integration to let uh, buyers talk to sellers. So that's why I actually took a trip over to Estonia. A couple of my coworkers had gone there before as part of the acquisition, but I went over with them as well to start doing more work on this Skype integration. And it was kind of comical because, as I mentioned, it doesn't want to be centralized. It doesn't want to be integrated with. It wants to be hidden, and it wants to be everywhere. And to the extent even you can't asynchronously reach out to a laptop or a computer because it's blocked. The data can't, or connections can't be made that way. So typically that's solved by having a place in the middle that you both go to, and that's how modern voice over IP and voice over the internet connections and communication flow. But this thing, they didn't have that. They didn't want to build it. They didn't want any of that. So their Skype communication is peer-to-peer. And they faked this relay point by having supernodes in the network. Those act as connection points. The problem is well, not the problem, but there were a mix of servers that Skype did invest in, not very many, but also they were able to find systems that they're installed on that did have outbound or inbound connections so that they could be reached. And so these supernodes acted as the kind of hop on, hop off points for Skype communication. So when a Skype client runs, it always has a connection to the relay or the supernode nearest it so that calls can come in. Anyway, so we went over there, and it was interesting in and of itself because they're a post-Soviet country. So they've got this weirdness where they want to hide this algorithm because it's their secret sauce. So they didn't want to share that. It's also a security by obscurity scenario where they didn't want anything about it getting out so that people could exploit it. It was like a differentiating feature, and they didn't want to tell it to us. They didn't want anything really to do with us as a corporate buyer, but they knew they had to do some things. Like we eventually got this Skype call-to-call thing. I think there was also a payments support. You could use PayPal to pay for Skype out or something like that. So there was a few integrations that we actually did build, and what else do I want to say about that? It was interesting. Oh, I know, there's one other chapter to this. So after that, we were building our stuff, and I got asked to do an M&A due diligence on a startup that Skype was considering buying. So this startup was called iScoot. Shout out to the iScoot guys. That's the team that I had in Israel. There was like 75 people at one point. Was at iScoot. But anyway, I do this due diligence. Shout out David Gedalia, who was the CTO of iScoot at the time. So I was talking to David for a couple of weeks. And in the end, just from a business and strategy perspective, this company, their product was an integration with Skype where from the mobile device, you could initiate a Skype call and it would make a cellular data call to a telephony system, which would then hop on to the Skype network. And they literally, I think, if I remember right, we had like Skype instances running, and we would fool the operating system to get in there and launch a Skype call. Anyway, they decided not to do it, but I kept in touch with David, and they pivoted, and they got more funding, and then they opened an office in San Francisco. They needed a VP of engineering, so David called me, and I remembered meeting him in London at Hyde Park, and we walked around Hyde Park for my interview for 3 hours or something, and so they decided to hire me as the VP of engineering because I had this Skype experience and this voice over IP background. So then that's the main end of the story. I worked at iScoot for several years. We eventually pivoted and we sold ourselves to Qualcomm, and I worked and I led that same group for another few years, working on IoT things at Qualcomm, and then I went to an IoT company and I left the world of voice over IP. So that is my story, and I'm sticking to it. Anyway, I thought that was kind of interesting because I had these weird ins and outs of voice over IP. I hope you all are well. This is a 20-minute experiment. Give me some feedback if there was something interesting, or tell me if I should just stop this insanity. We'll see how this goes. Give me some feedback. Let me know what you think. Bye.